Just give me 10 seconds till the recording. Yes, the recording has started. Now, let's start. So, you see, stability of slopes means what? Generally, if there is a slope, if there is a slope like this, okay, and there is a road, okay, where like the cars are moving, okay. Uh, so if the slope is not actually strong, then what will happen? The soil will break, like it will get detached, okay, and then there will be what? There will be the soil will fall down, okay, it will get detached and it will fall down and it may block the road, okay, and it may cause some damage. If there are some people here, then it may like harm the people, it may kill people, okay, if they like are standing somewhere here, okay, and it may cause accidents. Ultimately it's all about the failure of the slope. Okay, if this would have been just horizontal, there would have been no failure. But it's not horizontal, isn't it? It's inclined like this. It's inclined. So when it's inclined, there is a problem of balance and stability. And if the stability is not good, then the soil will detach itself. There will be failure, and like there will be some amount of damage that can happen to the people and to the cars moving near the slope. Okay, there will be some accidents. So stability of slopes is about how to like uh, prevent these failures, how to make these slopes stable, how to make these slopes stable. So our main aim is to make this slope stable, and for that there are lots of like analysis that are there, but we generally discuss just the specific and the important among them. Okay, if you search, there will be a lot of analysis, but we will discuss whatever is very important for from the BTech point of view. Okay, so now there will be like there are three types of failure you can write down. There are three modes of failure. Three modes of failure. Number one is the slope failure. One is the slope failure. Then number two is toe failure. Number three is base failure. Okay. Uh, First one is slope failure. Second one is toe failure. Third one is base failure. So we will be discussing each of the failure criteria one by one. So let us start with the first one, which is called as the slope failure. So for that, let me take a new screen. Any doubt in between, you can ask. If you have any doubt. I think the screen is okay now. Is it visible now? Is the screen visible now? Okay. So first one, which one is the slope failure? Number one, the screen gets blacked out when like the this when it gets minimized actually. So like it got minimized by mistake. So that's why you might have seen it blacked out. So uh, slope failure, toe failure, base failure. First of all, you have to understand that this slope failure, toe failure, and base failure, it happens in a specific type of slope, which is called as finite slope. it happens in a specific type of slope, which is called as finite slope. Actually, there are two types of slopes. Two types of slopes. The first one is this one, finite slope, and the second one is infinite slope. So first of all, we are like discussing this finite slope. After we complete discussing the various aspects of finite slope, then we will gradually move on to infinite slope. So let us first of all concentrate on the finite slope at first. So what will be the difference if you look at the name? What is the basic difference between a finite slope and an infinite slope? So if I draw a diagram of a slope, okay, yeah, I would also like to ask you to draw it along with me. So suppose this is the slope. Okay, so in the finite slope, basically, this part, this whole part, in a finite slope, this whole part is of a significant length, and it is not so big. Okay, so such that you can analyze both this part and this part. Okay, that means the finite element slopes, these finite slopes are like not so big, and you can easily analyze them from here and here. It is easily accessible to the people who are analyzing it. So that is generally called as the finite slope, where you can analyze both the top and the bottom. You can easily access the slope anywhere where you want to analyze. Okay, it depends on the accessibility. Okay, if you can access the whole slope conveniently, and you are not facing any difficulty in analyzing it, then you can consider it as a finite slope. But in infinite slope, what will happen is the slope is too big. Okay, in the infinite slope, the slope is too big like this, such that it is very difficult to analyze this part or this part. Okay, that means you might be analyzing this part, but it is very difficult to reach here and analyze. Okay, that means it's very difficult to cover both the parts in of the finite slope. Okay, it's very difficult. So that's why what happens is in an infinite slope, this is a case of an infinite slope. It's very difficult to access all the parts in the infinite slope. So what happens is that we select a suitable section from here. Okay, suppose this section I am selecting, this section I am selecting, and we analyze this section only. We select a particular part from the infinite slope, and then we analyze it. Otherwise it's very difficult to analyze the whole infinite slope. Okay, but in finite slope, in this type of slope, it's easy to analyze the whole one. But the infinite slope is very difficult, so we take a particular section. Am I clear till now? Am I clear till now?
Yes, sir.
Okay. So let's concentrate on the finite slope. So in the finite slope, the slope failure is generally happening around this portion. Okay. Toe failure is generally happening around this portion, and base failure is generally happening around this portion. Okay, please draw it. I recommend you to draw it. So you can mark it also. Slope failure, then this toe failure, and this one base failure. So these are the types of failure that happens in a slope. Please draw it. Now, in slope failure, this soil near the toe is strong. In slope failure, the soil near the toe is strong. Please write it down. Soil near the toe is strong. That's why the failure is not happening along the toe. Okay, and uh, and that's why the failure does not happen here. The failure does not happen here. It happens here. Okay, it's because the soil here is strong and here the soil is weak. Okay, and beta is very high. Okay, beta means we can say angle of the slope is very high. We generally consider the angle of the slope as beta, so beta is very high. Okay, so beta is the angle of the slope. Okay, and that is the thing that you have to understand. Then next we go to the toe failure. Next we go to the toe failure. Okay, so what happens is that in toe failure, any doubt? Any doubt? Someone has unmuted. Maybe you have any doubt, please ask. Okay, no problem. So toe failure, what happens is the soil below the toe and above the toe is homogeneous. Okay, that means in a toe failure, what happens? The soil below the toe and above the toe is homogeneous. Soil below the toe and above the toe is homogeneous. Okay, it happens in a steep slope. It also happens in a steep slope. Okay, and this toe failure is the most common mode of failure. Most common mode of failure. So in toe failure, the soil below the toe and above the toe is homogeneous. It is a steep slope and it is the most common mode of failure. Okay, then last one, it is the base failure. So I'll write it here itself. In base failure, generally the situation that happens is that the foundation part is not very strong. The foundation part is not very strong compared to the base structure, and the slope is flat. Slope is flat. In base failure, the slope is flat. Okay, and the soil, obviously, the soil below the toe is weak. Okay, so soil is weaker below the toe. Okay, so now there are some ranges of angle of internal friction and this beta, okay, for which the toe failure and slope failure happens. Okay, so let us discuss the ranges. There are certain range that is there for the slope failure and toe failure. There is no range for base failure because, sorry, the paint again went off. Let's wait for 10 seconds. Is it visible now?
Yes, sir.
Okay, thank you. So there are some ranges for phi. One second, let me darken it. There are certain ranges for phi and beta. Okay, for toe failure and for slope failure. Phi is what? Phi is the angle of internal friction. Phi is the angle of internal friction. So, if I look into the range for toe failure, phi should be greater than 3 degree and beta greater than 53 degree. And for slope failure, phi is less than 3 degree and beta is less than 53 degree. Okay, so please write it down. This is very important. I'm really sorry. I don't know what happened. Like there was some network issue or something like that. Okay, I'm really sorry for that. There has been some issue with the internet connection. I will not take much time. I will not take much time. Uh, can you see the screen? Can you see the screen?
Yes, sir.
Okay. So, like actually, like I somehow I left the meeting by mistake. Okay, don't mind the inconvenience. So, I hope you have understood what I have told you till now, and you also try to please write down some data. Like for cohesive soil, this phi is 0 for cohesive soil. This phi value is 0. Okay, so now one more thing that I would like to leave you all with is that there is one term which is called as mobilized uh, cohesion. Mobilized cohesion. Have you? I want to know if you have like got this term before, mobilized cohesion. May I know if you have got this term before, mobilized cohesion? Otherwise, like I will not go into details of this term, but if you have not heard, please let me know. Then I would like to like explain it to you, and then I can leave you with it. Okay, okay. So just understand. Okay, what do you mean by mobilized cohesion? Sometimes you will also heard about the term as mobilized shear strength. Okay, mobilized shear strength. This question also comes in the competitive examinations also. What is like mobilized shear strength? Then there will be four options. Generally in MCQs, multiple choice questions, they ask like what is mobilized shear strength? They give you four options, one, two, three, four, you have to mark. What is the correct? So now I would give you a different example, different point of view so that you can understand it in a much better way. Suppose you have an energy to like you have like 100 kilonewton weight taking capacity. You have. Suppose look at just yourself. You have a capacity of uh, taking 100 not kilonewton. Okay, just I want to become a little bit reasonable. Suppose you can pick up suppose 40 kg of load. You have the energy to pick up 40 kg of load. Okay, now if someone is so for picking up 40 kg of load, you will like spend some strength, isn't it? You will like utilize some strength for picking up 40 kg of load. Now, if someone is giving you 20 kg to pick up, someone is giving you 20 kg and telling you to pick up, then the energy that you will have in picking 40 kg, you will not be using that energy, right? You will be using only that energy which is required to pick up 20 kg. So suppose you have x amount of energy. Okay, you have x amount of energy that is required to pick up 40 kg. You can take 40 kg load, you have x energy. So out of the x energy, will you spend x energy totally in picking up 20 kg load? No, isn't it? You will spend half of it to pick up this 20 kg load. Am I clear till now? Just I want to give you a like example from a different point of view. Just till now, are you clear? Then I can proceed. If you have energy to take 40 kg load, okay, then if someone gives you 20 kg load, you will not spend that amount of energy, isn't it? You will spend half of it. If you are clear with this concept, please let me know. Then I can go to the next main concept. Just one student has understood, or what? Okay. So now, same way. Suppose now, like let us move from this part, and suppose you let me take the example of a soil. Suppose this a soil sample has a shear strength of shear strength of 100 kilonewton shear strength. It can take 100 kilonewton shear strength. Okay, now if only 30 kilonewton is applied on it, the soil has 100 kilonewton shear strength. This soil sample, it has 100 kilonewton of shear strength, but only 30 kilonewton is applied on it. Then how much of its capacity will it spend? This will spend only 30 kilonewton of its energy to resist the load. Okay, so that means it has mobilized 30 kilonewton of its capacity of 100 kilonewton. The soil has 100 kilonewton capacity, but it has mobilized 30 kilonewton of its capacity to resist this 30 kilonewton load. That means the amount of energy that you will spend for resisting the particular load is the mobilized value. Okay, you may have a capacity of 100 kilonewton. The soil may have a capacity of 100 kilonewton, but it will not spend 100 kilonewton every time. If the load on it is 30 kilonewton, it will mobilize only 30 kilonewton capacity from it. Okay, remaining 70 kilonewton will be saved. Okay, so that means it has mobilized 30 kilonewton out of its strength to resist the 30 kilonewton load on it. So, and the mobilized value is same as the applied value, isn't it? For 30 kilonewton applied load, you have to mobilize your 30 kilonewton capacity only. You cannot mobilize 25 kilonewton capacity, because then you will fail. This soil will fail if it mobilizes only 25, because now the 30 kilonewton load is more, isn't it? So it has to mobilize the same amount of capacity, okay, as the applied load. So that is the concept of mobilized. Okay, so please type Y if you have understood what I'm trying to say. Please be very clear about the topic of mobilized. Mobilized means out of its own capacity, it will spend only that capacity which is required to resist the load. And that is called as the mobilized strength, or in place of, in if it is for the cohesion situation, it will mobilize some cohesive strength. If it is shear, if there is shear force of, suppose what I have told about mobilized shear strength, if there is a shear force of 100 kilonewton, it will mobilize what? If there is a shear force of 100 kilonewton, it will mobilize only 100 kilonewton, isn't it? So that is the thing. So with this, I would like to end this class, and this topic, this mobilized word will be used a lot in this